Hello Internet! Today we are going to be making a low poly shader. So there's a few ways to do this. One of them is to turn off smoothing on your model. So every face on your model is going to have a normal. And if you turn smooth, well, every vertex actually is going to have a normal. And if you smooth those out, you can actually take a sphere and actually get it smooth. The other option is to have every normal that fits your triangle have the same normal, which requires you to actually duplicate faces. The third option that I just actually found out about a few weeks ago is to use a new feature in some of the graphics libraries. I believe it came out in either DirectX 10 or DirectX 11, which is relatively recently, like 4 or 5 years ago. So what this does is it's called a geometry shader. So we've kind of covered fragment shaders and vertex shaders in the past. So your vertex shader is going to decide where every vertex in your model is. And then your fragment shader is going to decide how to color the space in between those to actually kind of color that shell around your model. The geometry shader is a little bit different. So some of the advantages you get out of geometry shaders, we've actually played with them before. Tessellation is a geometry shader. What it does is it allows you to actually create additional data or create additional data inside your mesh inside of your shader actually. So as you're rendering this whole thing, you can actually use this to modify it. And we're going to use it to actually make an individual face for each of our triangles. So instead of rendering the normal triangles, we're actually going to divide each of those triangles into something a little bit better for what we need by actually separating it out and giving it a unique normal vector. So I've pulled up an example actually. It's on battlemaze.com, and this is a little bit old, and it's got some things I don't quite like. But it's also one of the very few geometry shader examples I could find for Unity. Not many people have played with this. A lot of people have stuck with the default like Unity tessellation stuff and not gone any further than that. We're going to do this. And from what I understand, you can actually do like billboard drawing and stuff, which they actually took out of Unity a while ago. So that might actually be something we might want to do in the future. So what we need to do is implement this method here. Well, actually, it goes down a little bit further. We don't need to implement all of this because they are actually simulating like lighting and stuff in here. But we do need this function. And so this is actually your geometry shader. And it's going to accept a triangle and 3 vertexes. And then it's going to output at most 3 vertexes. That was kind of weird. I have apparently done something to the code highlighting on this website. Anyway, so there is this. This is going to define the maximum number of vertexes you can output from your geometry shader. We're making a triangle, so that works for us. 3 works for us. Then you define the name of it. This can actually change. You just use one of those pragmas from your Unity shader. And then you define the type. So triangle is what we're going to be using. There's a number of other things. You can use a point. You can use pretty much anything you want. I think there's point, line, triangle, and a few other things. I don't remember what they are. And then you give it the input type. They actually define that further up. That's one of the things we're going to have to kind of play with. And then they give it a name. And so it's just a 3-dimensional vector, or it's just a vector or an array with 3 elements. And they're going to just be the 3 triangle positions. So there's also this triangle stream. And so a triangle stream is going to represent the output data. It's what you're actually kicking out. So you actually write the new information to the stream, and then that actually gets funneled down into your fragment shader. So what we need to do is similar to this. I'm going to just copy this. I already have the shader created, but this is the wrong one. So we have a low poly shader. That's literally what it's called, low poly shader. And what we want is we want to have some sort of geometry shader here. So just like we have our surface shader here, this is the default surface shader. Just like we do that, we can just copy it here. And then we're declaring a surface shader with surf as the name. We can actually declare a geometry shader and do that. So we give it the name so that it knows what function to find. And then now at least it should say there's a geometry shader with a function called geom, which is here. Problem is this v2g is some custom value that they're using, which we can't use. So we may have to do a bit of work here. We may need to add a vertex shader. Yeah, I think we're going to need that. And so what we're going to do is we are going to convert from our vertex shader, we're going to convert into something that we can use in our geometry shader, and then our geometry shader is going to output into something we can use in our surface shader. I think. I was not able to find anybody who had been able to get geometry shaders and surface shaders to work well together. I didn't find any tutorials or write-ups on it. So I'm kind of shooting blind here. So this could either go really quickly and just work, or more likely it'll just blow up in my face and I'll be editing this for days. So we've got this here. So what this gets us is it gets us 3 points in space. And so we have vector 1, or vector 0 rather, vector 1 and vector 2. And those are just the 3 points at the outside of our triangle. And so from those, we can actually do a few things. The first thing I'm going to do is actually calculate a normal value, so the direction that our triangle is actually facing. And to do that, we should just be able to plug in the normal here and say this is going to be equal to the cross product. We're going to normalize that. So it's going to be equal to the cross product of v1 minus v0 and v1 minus v2. The exact order of those may be wrong, but what I'm doing is you've got 3 points in your triangle, and what you want to do is draw 2 lines between them and then get the cross product between those 2 vectors. So you kind of create a plane and say these 2 lines form a plane, and what is the up vector of that? And that's what a cross product is going to give you. So the classic programming thing is you get, or graphics thing, is you get a right hand thing. And so what a cross product gives you is if I have, say, my thumb and my pointer finger, given those 2, I can get the 3rd vector, and that is the cross product. So we're giving it, this is our triangle right here, and so we want that, and so that's how that whole thing is going to work. And then we're just normalizing it so we get a value so that it's a length 1, and that should be relatively good. This should not compile. Yes, very broken. Oh. It can't contain other programs. We may not be able to do surface shading, which means Let me retry that. Okay. So I think, let me see here. Let me think about this for 5 seconds, and then we'll see where we are. All right, that took longer than 5 seconds, so longer than 5 minutes, honestly. So surface shaders don't work with geometry shaders. They're not supported yet. Should have read that before I did this. So we're not gonna do this. We're going to delete all of that. This is the wrong project. I had opened up our asteroid belt. We don't need that. I was just comparing how the lighting was working there to see if we could resurrect something. We can't. So we're going to need a pragma vertex of vert. That's not what I wanted. A vert and a pragma. Fragment of frag. And so this is going to define our vertex shader program and our fragment shader program. We already have our geometry shader. That's right here. And then we don't need any of this. Oops. So that can go away. And now we're kind of stuck with a whole bunch of fun stuff. But we're not going to get any lighting in this project anymore because I deleted it all. But it does mean we can follow this a little bit more. So what we need is a vertex shader or vertex to our geometry shader. That's what this structure is trying to do. And there's no reason we shouldn't take it with us. So that's exactly what we're going to do. And we're also going to take their geometry shader to their fragment shader object. And we will walk through how this is working. We don't need the input anymore. That was part of the surface shader. So in shaders, the vertex and the fragment shader and now the geometry shader, those are all separate programs. They're combined into the same file for just ease, but they're actually separate, and they take in inputs and then give out outputs. So they're more like functions, but they're technically programs on the graphics card. And so what these structures are representing, this V2G, it's sort of a naming style of saying vertex to graphics. And they're just shortening the name because why not? 2 because it's cool and neat. So it's passing 3 things: the position, the normal, and then the UV coordinate of the vector or vertex. And then each of these, after this colon, are actually where in memory that is stored. So there's, at least on the DirectX side of things, there's specific places that you need to store things. So there's like a position, a normal, a bunch of different places to store texture coordinates, and a few other things. You'd have to look these up to figure out what they're for. I don't know if it's too strict. This one and this one are probably fairly strict, and I don't think you have much freedom. People just use texture coordinates for pretty much anything they feel like. So yeah, you can see UVs, diffuse colors, specular colors. They use it for all sorts of things. So we are going to be using it to do some other fun stuff. Right, so we've got these 2 structures now. What we need is our vertex shader, which is going to be relatively simple, and our fragment shader, which is also going to be relatively simple. And we're also going to keep our geometry shader fairly straightforward for now, just because we don't actually need it to do too much. So this shader here is actually for randomly, like random waves on water, which we're going to get to. I'm going to use a different algorithm to make the waves happen just because I need more control over them. But this kind of gives that. So we need a vertex shader, which we're going all out on the copying. Might as well not stop. So we're going to take our vertex program is going to take in some app data, which is a Unity defined structure. And then it's going to return that v2g, which the output of this is going to end up going here as this argument right here. And so we need to set this up. They've got some phases. Those are all about the waves. We don't care about those. And then all they're doing here is transforming the whole thing into world coordinates. So they're doing it kind of funkily. Object to world. And then why did they convert it back to world space? That's a little bit. So I think the reason they were doing this is because they wanted all of these position changes to happen in world space and not in object space, and then they could scale it back down into world space or into object space. I don't think we care about that. So I think that will work. I could be very wrong here, and this could end up being in the wrong unit space, and then everything is just going to blow up in our faces. But then we'll learn something else. So, oh well. Let's see. We've got our geometry shader. That's all good. We don't need to worry too much about that. And then our fragment shader is the final piece of this puzzle. So we can just drop this in. And this is good, doing absolutely nothing interesting. It's literally just, the fragment shader just writes a color to the screen. It's what draws everything you're seeing on your computer screen. And it's really not very smart about that. It doesn't know anything about your vectors or anything like that. It gets your input, it gets this input, and then from that, it figures out what to draw on the screen. And that's pretty much it. So we should be able to actually just keep this here. And this should actually run now? Question mark, apostrophe, period, exclamation mark. Let me try that again because I'm pretty sure it's broke. Yeah. Unrecognized. App data is unrecognized, so we need to. There is an include that we need. Unity CG, which is just a standard Unity CG, or not CG, standard Unity include file in order to get you some of those standard definitions. There's a number of these. We've talked about them in previous videos, so you can check that out. It was in the planet shader, which is why I was looking at it previously. So tri-stream is undefined. What? I need to stop clearing those. I'm clearing them because I think they're from the previous one, but they're not. Tri-stream undefined. That's not what it said. What did it say? Unexpected token tri-stream. Unexpected. Weird. So we close our properties. Close that. And we close all of these. I wonder if those are the issues. That doesn't make any sense. That shouldn't be the issue, because that's correct. I'm not sure what's going on. We're breaking things, and that's not good, because I don't know what I'm doing. I think, though I'm not sure, I think we need to up our shader model. Because we need, so turns out this is only a DirectX 11 feature and a OpenGL like 4.5-ish feature. So you need to target that or it won't work. So I think Unity just crashed. Nope. It was just doing something weird. Ignore this. This is what happens when I have free time and bored. Worms of water. So our try stream is not supposed to be there. But that should be the name of what we're writing to. I wonder if it's just not, if we're just not using it and that's causing the problem. So I think we can fix that actually with this. So we're going to paste that. That was a lot of stuff. But what it does is it defines an output, which is just going to be each of our individual points in our triangle, each of our vertexes. And so we are going to output 3 vertexes from this because we're outputting a triangle. And we want to take out each of the positions like that. Pass in the normals, which we've calculated as our normal. And we don't care about anything else. Don't care about UVs. Don't care about diffuse. So I'm just going to comment those out for now. And we will come back to those probably in another video because I don't think we're going to get to lighting. And so each of these writes to our try stream, and then we replace those values again. So we're just reusing this output 3 times and sending 3 copies or 3 separate vertexes to this stream. And now it's getting even more annoyed. The heck? That doesn't make any sense. Unless I have incorrectly defined our geometry shader, which I don't think I have. So I think what we need to do is actually give it a little help here. So we need to give it the name of whatever it is we're passing in. So in this case, we're passing our geometry shader, G2F, into this try stream. That's supposed to fix this. All right, so the errors we're getting are our out variable isn't fully initialized, which is true because we haven't done that. And then there's an extra unexpected bracket, which I think we can just remove that. I don't think that's going to fix that, but we can definitely take the fallback shader out. We don't need any of that. Unity's got some fun stuff that it will add in if you have a fallback shader, but I don't want any of that right now. And then let's see, we've got our output isn't completely initialized. Position and normal, we can actually take those out. And that error should go away. Specular color, diffuse color, those aren't being set anymore. So this isn't going to work. So we need to give it just a color. So I'm just going to give it a bunch of ones for now. So this is going to be a completely white shader. And then we need to figure out why we're getting an error with that there. What's causing that? And honestly, I'm not sure what's breaking it. Oh, that might do it. Do we need to specify a pass? I don't think this is required. So in Unity, we actually talked about doing this in a separate for our planet shader to actually combine our shadow caster and our actual rings. But what you need to do is you need to add multiple passes, which I forget where you add that. Let's see where they're doing it. Right above everything. So right there, you define a pass, which is going to be, things are rendered in passes. So you'll render one pass, and that will just more or less be a step of your rendering. So if you're in our case for like the planet shader, we'd have two passes. We'd have one to actually render the ring, and then one to actually cast the shadows from the ring. In this case, it's a little bit more complicated. So, well, it's actually less complicated. We've got the pass here. And so we just need to close that like so. And now it stops complaining. Good. Okay, so that's all we needed to do. We've now got a single pass shader that should handle low polys. I'm just going to create a sphere. A sphere will be a good way to demonstrate this. It's probably not going to actually work. If it does work, something's broken. Which is a weird way to say that, but it is. I'm going to put this up here and make it bigger. And then I'm going to make a material that actually supports this low poly material, or low poly shader. And where is it? There it is. And then we're just going to drag it over there. And we're just going to get white out of this. There's not going to be anything fancy going on. Oops. I hit all the wrong buttons there. So there's not going to be anything fancy going on here. The only fancy thing is if you compare this to some other sphere, you'd notice that those lines are maybe slightly darker. And the only reason that would be, they don't even look that way. But the only reason that they might appear darker is because there's two, theoretically. I don't know a way to test that. Actually, yes, I do. So what we can do is we have this normal. What we can do is increase where we have our position here. We can increase each of those positions. So V0. I don't think we're using V0 anywhere. It's kind of weird. So anyway, we're going to do V0 plus equals our normal times 0.1, say. And so what this is going to do is it's going to just slightly move each of these out along a uniform normal. So it's more or less going to explode our, in this case, sphere or mesh along each of these triangles. And so it's going to do just a fixed size, but that should be fine. And I'm going to switch these to use our vectors here. because I think that makes sense. The only concern I'd have is that we might lose our position. No, I think this should be fine. Oh. Wait, what? I may have broken it a bit. A lot of bits. So I don't think you can do that. So ignore that last step. Let's do it the right way, I guess. And add our normal onto our position, which should look worse, but should work, actually. Yeah. Oh, I copied too much. So those can go away. And now, it's still gone. Well, this is weird. Where'd it go? I wish I knew. I don't know what is causing this. And it's frustrating. So we calculate our normal. Is our normal not right? It may not be. Let's do V0, V1. That didn't help either. Okay. Let's do float 3, 0, 1, 0. And so if this works, if everything's working, we're taking that normalize function out. If this works, our object should appear up here. Or should be at least moved up. But it's not. So something else is broken. It's not, well, maybe this is broken too, but it's not that right now. So let's get us a world normal. And we'll do a multiplication of our Unity MVP, which is going to get us into world space. Yeah, it's going to get us into world space. So we have to do all of this since we're writing our vertex and our geometry and our fragment shaders all on our own. We have to do our own lighting. We have to do our own matrix multiplication. All of that, we're on the hook for that. So this is what we're doing. We're getting our normal object space normal and transforming it into a world normal. And the idea then is to actually just add it on, plus 0.1, we'll say. That won't work. Times 0.1. And that should solve that issue, I hope. If it doesn't, I'm going to feel even more foolish because I was supposed to know this stuff. Cannot convert from a float 3 to a float 4. So our world normal is in wrong dimensions. I don't think that's going to work either. Oh, it did. Cool. And everything else actually worked too. So what you'll see is we took every triangle and projected it out. So if we didn't have a geometry shader, if I take that out, for example, this is just going, it would still be smooth. It would be like this. It'd just be bigger. Whereas since we're using a geometry shader, we get this fun pattern, which actually allows us to do some really cool stuff, which hopefully we'll get to in the next video, because this one, I thought I was prepared, and I was not prepared. So here's what we need to do. One, it's all white. We need to fix that. I think I have an idea on how we can fix that. But we'll have to, that'll be sort of our next step. Because everything now has its own object, we should be able to light this. Just do normal lighting. And because of the way all of the normals are set up, even normal, like standard lighting is going to work on this, and it will appear flat. So I think we can just start there and then build up from that. But this is relatively limited now. It doesn't cast shadows. It doesn't do a lot of things. So definitely not done yet. But I think we can do some work here. So I'm going to leave it here. If you guys have any suggestions, because I may need them on this one, let me know in the comments. And until next time, see you, Internet.